Okay, so let's start. Uh, Sorry about the interruption. There was a network interruption in Colombo. So let's start. Right. So this is sort of a practical session that we have arranged for you, and first of all, we need to learn about configuring a manageable switch. Now, in theory, you have learned about computer networks, different layers of the OSI model, and the switches actually works on the layer number 2 and above. So, uh, hope you would hear my voice. And there are several ways to configure a manageable switch. So if you have a physical switch with you, you can use a console cable and a terminal client like SSH PuTTY or Telnet to configure a switch. So there is a backside, there is a console port where you can fix the cable and back to the computer. Then you can use a client to configure. However, uh, due to practical issues, we don't have switches to give all of you, and especially in a virtual session like this. So we use a simulator to do the practicals. Hello, can you hear me properly?
Yes,
Sir.
Yes, okay. So some people are complaining that,
Yes.
right. Okay. So now the second thing is through a command line interface. Uh, when then IP address is configured to the switch. And third option is to use a web interface of the switch. Right. So actually in this practical, we basically use this second option through command line interface via SSH and Telnet. This feels visible in the simulator. And the fourth option actually through the simple network protocol, which is supported by almost every switch modern switch which is being sold today. So if there is a central software which you can manage like in a large network environment, you can't go to each and every switch and do the configuration. Therefore, through a network protocol, you can manage a switch. And the final option is vendor specific management protocols and applications. For example, now major players like Cisco have provided the central software to manage their equipment. So if you buy the subscription, you can actually use this centralized software where all options are possible through the web interface. So in this course, we are actually learning how to do the configure switch, network switch via this command line CLI interface. So let's go ahead. Right. So everybody please listen to me and make your own notes. Right. First of all, when you log into a uh, switch, you will be prompted to go into the user mode. So actually this is very important because first information that CLI mode prompt that you get is greater than sign like this as I show you in the slides. So this is called user mode. So the user mode is something like your normal user account on a Windows computer. Right? You can use the software, but you cannot install anything and you cannot make any changes like. So similarly in a switch, you can view some information related to that particular switch configuration, and you can't do much. Then you have another mode called privilege mode. Uh, so in this privilege mode is like some administrator account on your PC where you can install the software, you can make the changes and so on. So in switch also, if any configuration change is needed to be done, you have to be there in the privilege exec mode. So we call it privilege mode. And when you go to that mode, it is identified by a hash symbol, right? So we call it hash prompt. When there is a from user mode, there are commands to go to the privilege mode. And under the privilege mode, there are two configuration modes. Like when you go to the privilege mode, uh, when you want to make a change to a switch which is affecting globally, like a switch name or switch entire change required for entire switch, then we have to use a global configuration mode. So when you go into that mode, the prompt changes to within equal brackets config with the hash sign. So from this prompt, you know that you are in the uh, global configuration mode. So as the name says, it is affecting the entire switch. Then if you want to change the IP address of a particular port, because switches have multiple ports, if you want to change, this operational mode of a interface, then we have to go to a interface configuration mode. Then the prompt will come as config -if, like this with the hash prompt, right? So now these are the four modes that you would see in a typical command line environment of a switch. So now I am going to tell you the commands needed to go from uh, each mode. So initially you will be at the user mode. So from user mode to the privilege mode, we have to use a command enable, enable, right? So if you want to go to user mode from user mode to the privilege mode, you have to use enable command. And to go back, you can type either disable or exit. Both commands will work. Either disable you can type or you can type exit, right? Then from privilege mode to the global configuration mode, the command is configure terminal space terminal, right? Then to go back, you can use the command exit, right? So, and if you want to go to the interface configuration mode, you have to use the command interface with the interface name, right? So it is already given. So to go back, you can use exit always. So this is the sort of modes that you need to know before we start configuring a switch. Okay, so let's move forward. Right. So then the slides that these slides are all available in the LMS, so you can download the slide set and the commands and all. And remember that only the commands which are in the slide set is maybe not enough for you to do the practical examination. So you have to study the commands given in the book also. So therefore, remember that and try those commands uh, at your leisure. So let's go to the simulator and we will configure a switch. So Right. So this is the simulator that we are using. This is called Cisco Packet Tracer, and you can install the Cisco Packet Tracer in your computers, and you can actually do the practicing at your home even. So this particular simulator, we need to know a few things. It's you have used Microsoft Paint uh, to draw some images on the computer. Similarly, in this simulator, you have to draw the equipment and do the configuration. So let me little bit size this so that I can take the practical guide onto the other side. Right. So this is the first practical that we have. So we are trying to do this. And in the meantime, I am going to show you how to use the simulator. Right. So, first of all, you need to learn about this simulator. It's like a normal paint. So, if you want to have a new canvas to draw, you take file new. And if you want to save the file, you can use save button as normal Word document. You can save. So, for the exam also, we will give you the special file which will be automatically evaluated. So, you just have to open that particular file and work on, and always use on the same file. Don't use save as at the examination. But for your purposes, you can always use save as to give a name. Right. So that is a fact that you need to know. Then in the bottom left hand side, you have this toolbox. So in the toolbox, you have these devices. So if you move your mouse closer, you would see network devices are coming as a first tool set. Then end devices are coming as a next tool set. Likewise, then other components are coming. Then this connections types are coming, right? Likewise. So first of all, in order to draw this topology, so we go to the network devices. So under the network devices, the subset of tools will be shown. First, you would see the set of routers where we use for sending packet to different networks. Then you have the switches. So most lay for the practicals, you use routers and switches. When you select switches, the the switch types that we can use in the uh, topology can be seen. So what you have to do is, as this diagram says, there are 2960 two switches are there in the topology, and two PCs are there. So what we do is, we just simply go to select this one of these uh, switches from the toolbox and drag and drop into the canvas like this, right? So we need two switches, so we drag and drop, right? Then uh, you have two PCs. Uh, so we go to the end devices, and we select PC 0 and PC 1 like this, right? So uh, you can rearrange the things like this. If you want to erase a particular device, you can simply select using this select tool and select delete button. So if it will ask, do you want to delete the PC one? If you want, you can delete. So I don't want to delete, so I am canceling it. Likewise, if you want to remove a device, you can remove. Now, this the bottom part is called display name of the equipment. So if you want to rename it, you just click on the device and you can rename. So if you want to rename it as PC2, you can do so and press enter. It will work. But we need a display name as PC1. So I am renaming it back to the way that I want, right? Then most important thing is uh, how to connect this equipment, right? So if you use mouse, uh, if you use mouse, uh, it will show you all the network ports that are available in a particular equipment. So in this case, you would see that this device name is switch 0 and there are 24 fast Ethernet ports are there with the port numbers uh, fast Ethernet 0/1 up to 0/24 and gigabit Ethernet 2 ports. So likewise, if you click on the mouse, the PCs, on top of PCs, you would see the device model, the device name, whether there are IP address set and all those information. Okay, so let's connect the PCs to the switch. So watch carefully. How do we do? I will go to the connections tab here. Then there are different connection types are there. So as the topology shows you as a straight black cable, so we call it a straight through cable. So if you click on the straight cable like here, then we can try to connect. So we can connect the switch like this. So first we click on a PC, right? Then we select the fast Ethernet 0 because we are attaching a UTP cable. So we click there. Then the wire will be attached like this. Then we go on and click on the switch. Then the ports will be visible, which port we can select to connect. Now, according to the diagram that we are connecting PC0 to switch 0 fast Ethernet 0/1. So I am going to select fast Ethernet 0/1. Then the wire will be attached like this. So similarly, we can connect the other ones as well. So switch to switch connections are port number 2 here, fast Ethernet 2 to fast Ethernet 2. So we will attach a cable. It's again a straight through cable. So we click the correct connection and we click and connect fast Ethernet 2 to fast Ethernet 2. Right. So, and for the uh, third one, we again through the straight through cable, we uh, connect from fast Ethernet 1 to PC's fast Ethernet port. So, we select fast Ethernet 1 here and wire attached. Then we go and select fast Ethernet 0 like this. So, we have drawn our topology, right? So you can actually connect and you can do with me if you are in the computer. So you can attach these cables and draw your topology. Right. So next thing is to do the configurations. So drawing the cables and connecting cables is very much important because if you don't do, I mean, you are stuck from there. So if you can connect like this, so you can go forward. So shall we discuss about the importance of the configuring the devices. So in the switch 0, this description is given, right? So we will start configuring uh, the switch. So switch 0, uh, it says name is DMCS main lab. So this name, if you are you want to configure, you need to know how to issue the command. So we will click on a switch here, right? So this is the physical view of the switch. If you click on the switch, so actual switch is something like this. The way the look will be same. So these are the ports available. This is top part is the front side and the other part is the back side. So Likewise, the port numbers will be visible like this. So the actual Cisco switch, a 2960 switch is something like this, the actual image. The backside is also shown, and this is where the console port is. If you have got hold of physical switch, you can configure using the console cable. So now we are going to configure it using the command line interface. So this is under the physical tab we are watching. So we click on the CLI. So then we have this command line interface here. Then when you press enter, you will get a prompt. So the switch prompt is something like this, as I have told you earlier. This switch prompt ends with the greater than symbol. So this is the display, this is the name given to the switch. Initially it is labeled as switch. Then we have this prompt, the greater than sign prompt. So which mode we are in now? මම කියලා දුන්නානේ mode 4ක්. I have educated you about 4 modes that a switch can be in. So
User
which
mode.
we are in the user mode.
User mode.
Yes, user mode. Yeah, right. So now we want to change the name of the switch. So uh, I am using a notepad to uh, type the commands, right? So the commands that is needed to change the name, I will type here. So now this name is affecting the entire switch. So if you want to make a configuration change affecting entire switch, which mode we have to be in? Is it user mode? Is it privilege mode? Is it global configuration mode? Is it interface configuration mode? Which mode we have to be in?
Global.
Global configuration mode, because we are changing a name which is affecting the entire switch. So the command is like we are in the user mode now. Here we are in the user mode. So we have to go to the privilege mode first. So the command that we are using for that is enable, right? Then the uh, to go to the global configuration mode, we have to use the command configure terminal, right? So that is to go to the global configuration mode. Then to change the name of the switch, we have to use a command hostname. So this is the command that is needed to change the name. Then we give the name. So here you have to always use as matching the case. So I have 4 capital letters, that is DMCS. Then simple letters main. Then L capital, A B simple. So we have to type the name exactly as is. Otherwise you won't get marks, because the examination is automatically evaluated. So at the end of the exam, you know how much marks you got, right? So then this is the command to change the name. So shall we change the name? So I can type it in the console, or else if you have typed it, uh, you can actually uh, copy and paste this on the console, right? So uh, I'm going to copy this thing and paste it here, right? So as you can see, now after typing the enable command, switch has changed the mode to hash prompt, right? Then I have typed the configure terminal, then switch has changed the name to config, right? Then after issuing the hostname command, to change the name. Instead of switch here, it will be changed as DMCS main lab, right? The name has been changed. Then to go back, we can type exit, right? So the name has been done. So then we need to know how to set a password, because you know why. When you have a switch in a computer network, if you allow anybody to go to the privilege mode and make any change, then it will be a disaster, right? So because of that, you need to prevent people from logging in without issuing a password. So we need to know how to set a password. So first of all, uh, you have to set a privilege mode password. So we call it enable password. So set up enable password. Uh, this in order to do this, the command is since we think that we are in the user mode, so we start from there. So we have to go to enable and we have to go to the privilege mode. Then we have to password is affecting entire switch, so we have to go to the global configuration mode by typing configure terminal. Then we have to set the password, so we say enable password, then the password. So in the practical test, we practical guide, we gave the enable password as test, so we can set the password like this. So the enable password test. So now actually we can see where we are now. We are in the privilege mode. So we don't need to issue the enable command because we are in the privilege mode. If we were in the user mode, we have to type enable and come to the privilege mode. Then type configure terminal and go to the uh, global configuration mode. So I will start from configure terminal because we are already in the privilege mode, like this. So then we can say set the password. So we type enable password test. So we have set this password to the switch, right? Now, how do we know whether it has been applied or not? That's the main issue. So we go back by typing exit. Then we have a way of looking at the switch configuration. So the command is displaying switch configuration. So command is show running config. So this is the command to display the switch configuration. So we say show running config, right? So when you press enter, it will see the current running configuration of the switch, right? It says host name DMCS main lab that we have set and enable password test. So the password has been set, but if somebody looks at the running configuration, your password is visible, isn't it? See, right? So that is the problem of the enable password, because if you set it, it will be plain visible on the screen what the password is. If somebody has access to this configuration of the switch. So then we press space bar to go down. Likewise, then we can go back. So this is the way to see the running configuration. So the weakness is the enable password simply stored as a text. So in order to alleviate this problem, we have to set a secret password. So again, it is an enable password, but it is actually scrambled uh, to set the secret password. So I am going to set the secret password. So in order to have the secret password set, the commands are so supposing we are in the user mode, we type enable, then we type configure terminal. Then the command to set the password is enable secret and then the secret password. So in this practical, we have the secret password as my test. Okay. So this my test has a priority over enable password. So if you have set the both passwords like enable password and the secret password both, the priority will be given to the secret password. Remember that. So now shall we test this um, the secret password? So I am going to type it configure terminal and then we have typed enable secret my test and we go back and we see we again list the running configuration. Show running config. So now you could see on the screen host name is correctly set and the secret password is set but it is not actually visible what the password is. It is like scrambled in the screen. So because of this nature, the secret password is more secure because it is not visible to outside after setting up. Then enable password we have already set test. However, if the secret password is set, it is having a priority over enable password. So this is how we set the secret password in order to go to the privilege mode. So let's test this. So I am going back by typing exit to the user mode. Sorry. So from user mode, if you type enable, then it will ask for the password. Right. We have set now enable password and secret password both. So which one I should give here?
Secret password.
Secret password. What is the secret password we set in the practical?
My test.
My test. Okay. When I type my test, it won't display anything on the screen, but you have to type it correctly and press enter. If it is properly done, you can go to the privileged mode. Right. So this is the way that we set the password and test it. Right. So I will give you about 5 minutes to for you to try it in your computers in the lab, and you can do it yourselves uh, by drawing the topology and set the passwords. So please do so. Regional centers, I think you are following. So allow students to do the work from their own if they are working on the lab. Right. If they want to ask some questions, you can relay the questions to me, through the voice. Uh, if you have doubts, you can ask over the Zoom. Okay. So, regional centers, do you have any doubts?
Sir, sir, can you show me the last command you used
For what?
to password?
To change the passwords. So it is
No, no,
here.
not
Uh, uh,
not that one.
uh,
The last one you have typed password within inverted commas in the
uh,
CLI.
no, not password is my test actually. Here
Ah, okay.
it's given in the practical. Yeah, most students are asking for this recording, right? So I will give the recording, no problem. But the purpose of this practical is to do it by yourselves, right? So I will give the recording anyway. And actually, all these recordings, one by one, is already uploaded into the LMS. So if you have gone through, you won't be asking this question, right? Because how to do this each and every practical we have uploaded the already uploaded the videos one by one. So this one also I will give, no problem. Right, so let's go ahead. Right, so there are two other things we need to do. How to set up the console password. So console password is actually the password needed to go into the user mode. Now for example, if you have a computer, you might have administrator password. Again, sometimes you might have a guest password. So likewise, in order to go to the user mode, you can set a password. We call it console password. So to set up a console password, this is the command set. So enable to go to the privilege mode, configure terminal, go to the privilege to the global configuration mode. Then to set up the console password, this is the three commands needed. Line console 0 password just wait. So the password actually I am using the password given in the practical guide. Then command is login. These three lines are essentially needed. Then we can type exit to go out. So I'm going to try this thing. Then we can type exit to go back. So whether the password has been set or not, we can see it using that show running config command. So we type show running config command and it will be visible here. Now press space bar to go down. See the line console 0 password just wait login. So this is there, right? Okay. So you could see, right? So actually in the CLI, command line interface, you could when you are typing the command, right, configure, so it is cumbersome to type the everything, right? So if you type configure and press tab, the rest of the command will automatically appear. Now terminal TER, when you press tab, the command will automatically appear, right? So that is one way, right? So half of the command if you type, then if you press tab symbol, tab key, the command will come. Then the next thing is, since we are having this lot of commands to be typed, we can use the abbreviated form. Abbreviated form means without typing the entire command, we can type a small portion of it. Now, for example, for the enable, you can type en, right? Instead of typing enable, right? So, likewise, for the configure terminal, you can type conf t, likewise. Okay. So, from now onwards, I am going to use the short form so that we could learn the short form, and at the exam also you can use the short form of the command because you don't have to type the entire thing, right? So let's see now the other side of the practical. So this one is to the other switch, right? So shall we set those passwords, I mean to the configure the other switch, right? So switch one. So I am going to type the command set. Correct me if I am doing it wrong, right? So the other switch also we think that we are in the user mode. First we'll set the name, right? So we type enable, right? Then configure terminal, conf t I will use. Then uh, we have to set the enable, so set host name. So we set host name, right? DMCS special lab, right? So that we type exactly as it is, right? Then we need to set the enable password. So we are in the configuration mode, so we don't have to type it again and again, enable conf t. So we directly type the command set in the order. So the enable password we have set as Nisachara. So we say, because I have selected this password because this network admins are always working at night, so we just just as a abbreviation in Sinhala is you are working in the night, so we call Nishachara, right? Therefore I have chosen a password Nishachara, so you can choose any password for your switches. I just selected this just to have a nice view. So, so the enable password we set as Nisachara. Then secret password we can set enable secret as Mother Pavana, right? Okay, so the console password we can simply set as line console 0 password insecure login, right? Then the last one is called virtual terminal password. So the virtual terminal password is the password that we set to access the switch remotely. So console password is when you are having in front of the switch, you can use the console password using the console cable. But for the remote access, we need to configure virtual terminal. So the virtual terminal passwords are, again, you can say line VTY there are 15 remote login terminals in a new switch. So we say 0 to 15. Then we can say password Siri Mayura. So that is the password that I have given in the practical guide. And then type login, right? To set the password. Okay. So, and then we can type end to end the configuration and come back to the privilege mode. So these are the full set of commands that is needed to configure the switch 1. So I will explain again. Enable is to go to the privilege mode. Configure terminal conf t is to go to the global configuration mode. There we change all these settings because it is affecting the entire switch. So then we set the host name as this given. The command host name can be used. Now you know the command to set the enable password. So we set enable password Nishachara as given in the topology. And secret password is Mother Pavana. That is also set. Then console password, to set that we need 3 lines. Line console 0. Then password and the password that we are setting. Then we have to type login, right? Then for the remote access, again, command set 3 commands needed. Line VTY 0 to 15 because there are about 15 remote access. That is altogether 16 remote access uh, lines which can use. So every line has to be protected. So we set password for all, and then we say password is Siri Mayura because it is given here. Then login. Then finally we say end. So this is the entire command set to configure the switch. So we copy this and go to the switch, right? And go to the CLI and try to paste this, right? Then it will work, right? So now we can issue the command show running config. So I told you that show running config is the full command. So instead of show running config, we can simply type show run, right? Because we are using the shorter form. So we type show run and then whether we have done all these things, we can see. So first it says hostname DMCS special lab, it is set. Then enable secret, the scramble password set. Then Nisachara, it is set, right? Then we press space bar to go down. Then you can say line console 0, password insecure, login, it is set. Then you can say line VTY 0 to 4, password Siri Mayura set, and then 5 to 15 again password Siri Mayura set. That means all together 0 to 15 Siri Mayura password has been set. So now that means our configuration is done correctly. So we know that our practical, this part we have completed, right? So now most important thing is to save these configurations, because when the switch powered on and we make the change, and without saving, if we turn off the switch, right, all the configuration that we need will go away, because we are changing the running configuration. Running configuration means when the switch has booted up, the whatever the things they are in the memory, which is loaded from the initial configuration file of the switch, will load. Then when we make the change will only affect the running configuration in the memory, right? If you want to save it and reload at the when after the power is off and turn it back on, so you have to save it. So the command to save the configuration is this: copy running config to startup config. That means the running configuration we will save as the startup configuration, so that when the power went off, when the switch again booting, turning on, then the startup configuration file will be read and it will be loaded into the memory. So like a computer, switch also has operating system. So when we save the file, the configuration file, it will be automatically loaded when the power comes back up. So uh, we now shall we save this configuration, copy running config to startup config. Right. So I'm going to save this. Then it will say destination file name startup config. We press enter again. So then it will save building configuration. Okay, that means it is saved. So now the people who are doing the practical with me, you can configure the switch one as well. I will give you some time. So please start configuring the switch number one. So the all the commands are given here, visible for you, visible to you, and then you can try and configure this and save the configuration. So you do it yourselves, please, with me, so that you can ask questions if needed uh, when you do that. Okay. So I will give you again 5 minutes to do the switching, the saving, and the switch one configuration. Especially in the regional center laboratories, if you have doubts, you can ask over the line so that I can clarify. Okay, have you understood this concept so far? Right? Is it okay? Right? Is it okay, all of you? Right? People participating from the Zoom and uh, is it okay?
Okay, sir.
Okay, right. So let's go ahead because we have a lot of footprint to cover. Uh,
So we can't hear you.
Hello? Hello, can you hear me?
Yes, so now.
Okay. So uh, we try to configure the IPs. So we click on the PC and we click on the desktop tab, and under that we click on the IP configuration. So in that the IP is given here. So we type it 192.168.0.1. So the subnet mask is /24, that is 255.255.255.0. We have learned this in the IP, that theory lesson that we have learned before the cat. So we set the IP address, then we close, then IP will be set. Then for the other PC, so PC also we go to the PC and we go to the desktop tab, we click on the IP configuration and we set 192.168.0.2. Right. Okay. So and we set the IP. Right. Then one thing I forgot, how to set the login banner. So that all I will show you under the switch configuration. So the command is so login banner. Again, it is affecting the entire switch. So we go to the global configuration mode, enable conf t. Then we type banner MOTD. So MOTD is message of the day. So that is the shorter form MOTD. Then we press space. Then we had put the hash symbol. Then we type hi. This is for authorized users. So we end with the hash symbol like this. right? So this is the way we set up the banner, and so we will set this thing in the switch 0. So you can set up any banner, like this text can be changed. So to anything, right? So I'm going to set this thing for the switch 0. Password will be asked. So it says banner message of the day, hi, this is for authorized users. So it is set now. So if you exit and come back, sorry. Then it says, hi, this is for authorized users. This is the place where the banner will get displayed. So you can set the login banner like here. So using the command that I have typed. So banner MOTD hash. After that you type the banner, the message, and then we end with the hash symbol to mark it the end. So this is the banner setting up command, right? So hopefully you understood the concept. So now we can save the switch configuration as copy running config to the startup config likewise, and file save also works, right? So I'm going to save this uh, practical one, right? Okay, so now we have completed the practical one. So hopefully you would have tried a little bit, and you can, I will give the recording so you can try it on your own at leisure, right? So then we move on to the practical number 2. So everybody finish up doing the practical number 1 and save it and keep it. So if you want to take it home, you can get it emailed to your personal email account or student email account. No problem. So now let's learn about the practical number 2. Again, this is very important lesson to know. So under the practical number 1, we have learned how to draw the switches, how to set the PC IP addresses, how to go to the CLI, how to go to privilege mode, configuration modes, and so on, and change the host names and so on, and setting up the passwords. Now, in the practical 2, actually, what we're trying to learn is how to group the PCs. Now, I take real world example. Now, for example, supposing you have 50 students in a class, right? And I want to group them uh, to a different task. For example, so we are organizing a sort of a party. Then some a team can work it as logistics committee, one can work as food committee, and another team can work as this inviting the guests, uh, that the uh, welcome committee. Likewise, you can group. So in a switch also, based on the purpose, for example, in actual institution, you might have finance department, HR department, marketing department, and so on. But we don't buy switches for each and every department. If the single switch can handle, what we can do is we can group the PCs connected to that switch in a different groups, so that they can see each other in the group, but other groups can't connect to the PCs which are not in their group. So we call this concept a VLAN. So instead of having all PCs in all one network, we are dividing the switches to the multiple subgroups and assign ports which are connecting the relevant PCs to that group. So that is the concept that we are learning here. Now, for example, in this particular practical, we have two groups, right? Say if I take an example, PC0, it says VL20, so that VL20 is one group. So uh, if you watch this particular diagram, right? So another member is there for the VL20 group, that is this one. PC3 is also in the VL20 group, and then the switch and switch to switch connection is there here, and after then going through that switch to switch connection, there is another member in a different switch as well, but belonging to the same group. So this is actually in the real world also. Now the finance department, the main group will be there in the building A, and the payment counter may be there in the building B. But payment counter also part of finance. So, and in the real world also, in the Open University also, finance division is there on the Narayanpeta side, but the soft counters are they are in the Navala side. So all are connected using this concept, where we can divide the ports which are connected to that particular PCs into a single group. So we have to know this particular concept of grouping ports. We call this VLAN concept. So how to VLAN a switch, we need to know, right? So let's learn how to do that. So first of all, I will close this and take a new topology. Right, like this. Then we will draw this topology together. So if in the regional centers also, you can draw the topology now with me. So then we will configure one by one, right? So first I will go to the network devices and then take two switches, switch 0 and switch 1. Both are 2960 switches. So I take 2960 switches, 1, 2. Right? Then I need 1, 2, 3, 4, 5 PCs. So I go to the end devices and select the PCs, and PC0, PC1, PC2, PC3, and PC4. So I have drawn the switches. Then I have to connect. So the port numbers are given, which port which we are connecting. So PC0 to port number 4 of switch 0. So I take switch 0 to this side and switch 1 to this side. Now it's okay. So now I am going to connect. So I go to connections tab and I connect one by one. PC0 to the port number 4. PC1 to port number 6. PC3 to port number 1. And PC2 to port number 2. Then switch to switch, port number 3 to port number 3. and port number 13 to PC4 in the switch number 1. Right. Then now the steps that we need to configure is first in a switch we have to create the group name. Okay, create the group and group name, right? So that is the first step. So I'm going to use this notepad. Right. So first step is to creating a VLAN. So first is we have to create the VLAN ID and VLAN name. So it has to be done using the global configuration mode. So we type it like enable conf t. Then we type identify VLAN. The VLAN 20 and VLAN 30 is there. So we say VLAN 20 and we give a name VL 20. Then VLAN 30 name VL30. So this has to be done in both switches because we are creating the VLAN. So shall we do this? So we copy this command. Right. And put it on the switches. We go to the CLI and paste the command. So that we did, right? For the other switch also, we go to the CLI and we paste. Then we type exit. Right. So the VLANs are created in both switches, just giving the names, right? So now after we configuring that particular VLANs, shall we see whether those are created or not? There is a command to do that, right? So the command is show VLAN brief. So this is very important. The command, the show VLAN brief, because this one shows you the ports and the VLANs created in a given switch. So as you can see in this particular diagram, VLAN ID is given VLAN number 1, name is default and status is active, and all the ports that are there in the switch are member of VLAN 1, right? It's a single group. Now we have created two VLANs, VLAN 20 and VLAN 30, but there are no members, right? So that means the ports that connecting this particular topology, we have to make members. Now, for example, now according to this topology, PC0 is connected to port number 4. Port number 4 has to be a member of VLAN 20. But currently it is a member of VLAN 1. So we need to change that, right? Similarly, port number 6 is connected to PC1, which is a member of VLAN 30. So we need to make port number 6 member of VLAN 30. Likewise, so the assigning the doing the membership, there's a set of commands. So that we will learn now. So මේකට කියන්නේ port membership කියලා, we call it port membership, right? So this is the command set, right? So we have to issue this in global configuration mode, and then we have to go to the interface configuration mode, because this command only affects a given port because we are changing the port membership. So the command that we are issuing has to be there in the interface configuration mode. So how do we go there? So first of all, we say enable, so that is to go to privilege mode, conf t to go to global configuration mode. Then we type the command interface so shall we change the membership of port number 4, which is VLAN 20. So we change the membership. Interface FA 0/4. That is the way to go to that particular interface. Then switch port mode access, because the mode of the particular group, which is a particular port which is connected to a PERSI, is access. Then we change the membership. So in the slides, I have commands for all these. See, this is the command given in the slides. Switch port mode access. Then switch port access VLAN. We give the VLAN ID. Then we type N. So switch port mode access. So VLAN ID is 20. And then we type end. So shall we do this and see the results? So for the switch 0, now our initial setup, there are no members for the VLAN 20. So after we paste this and type show VLAN brief, now we see VLAN 20 has one member, port number 4, right? Likewise, we can use the same command to change the membership of the other ports as well, right? So port number 4 that we already did, right? So the others we can easily do. So we will do it on one go, because one by one we can type the command. So we have enable conf t, and then we have to go to particular interface. So interface. So we did for the port number 4. So we will do for the port number 6. So interface FA 0/6. Then switch port mode access, switch port access VLAN. So VLAN PC1 is connected to VLAN 30. So VLAN 30 we will set. Right. So we don't type N because we need to do further configurations. So because of that, then we go into this one, which is port number 1. So again, we go to the interface FA 0/1, switch port mode access, switch port access VLAN 20. So that is PC3 belong to VLAN 20. Again, we go to the next interface, that is port number 2. So switch interface FA 0/2, switch port mode access, switch port access VLAN 30. And then this one we will configure separately. So all the other parts done. So we say end, right? So using this command set, we can configure it in the one go. As you can see, we are using the 3 commands. Go to the port, then change the mode to access, then change the VLAN ID of that particular port to given VLAN ID. So these 3 commands needed for one port to change one port. So we need to change another 3 ports. So 3 by 3, we had 9 commands, right? So we copy this and paste it on the switch. So I have a typing mistake. So I will here I had typed mistake, so I will type it again. Now done. Now if we type show VLAN brief, all memberships are now okay. So VLAN 20 we have 2 members, VLAN 30 we have 2 members in the switch 0, right? For the switch 1 also we have to do this because we have 1 member there. So hope now you understood this concept. So I will give you some 5 minutes or so to configure the switch now. So using the diagram that we have and the commands that I have typed, you can do it for the switch 0. And for the switch 1, I will type command set again. So you do it while I will type the command set. Right. For the switch 1, port number 13, and we type in. So this is for the switch 1, right? So the entire set of commands are given. So hope you could type this thing in your PCs and do the configurations now, right? So I will give you the time. You have questions, you can ask now. Right. So hope you would have typed the set of commands and pasted it. So it is pretty easy stuff because we just copy one command set and make the change, read into the other interface and paste it like this. And then we compile everything under the notepad that put it there in the switch. So that is the way the easiest to do, right? Okay, so then we have configured the port memberships of switch 0. There are 4 PCs and one member in the switch 1. Then there is a connecting wire like this. So in the connecting wire here, display this one, right, has to carry the traffic of VLAN 30 as well as traffic of VLAN 20. Because so if another PC added up later, say PC6, PC5 or something with the VLAN ID 30, then the the members of VLAN 30 has to be communicated with each other as well as members of VLAN 20 has to be communicated with each other, but the traffic has to go on the same line, right? So if there is a common port is used to send the traffic of multiple VLANs, then we have to label the packets of each VLAN in a manner that it will not clash with each other. So this particular line, the communication link, which carries the traffic of multiple VLANs, we call it a trunk, right? So we call it a trunk, this particular line, right? Because it is carrying traffic of multiple VLANs. So the ports connecting the trunk has to be configured separately. So the trunk port configuration we have to learn. Trunk port configuration. So how do we do that, right? So that command I will give now, right? Configuring a trunk port, right? So let's do it for the switch 0. So type enable configure terminal, right? Then switch interface. The port number is FA03 for the switch 0, FA03 for the switch 1 also. So same command could be used for the both switches to configure FA03 switch port mode trunk. Earlier it was access. Now the mode will be changed as trunk. Then the signaling traffic of the trunk port has to be sent over different VLAN. So this is a requirement. Therefore, we have a native VLAN ID as 1. So this number can be changed in different networks, but for the purpose of practicals, we always use native VLAN 1 to send the signaling traffic. So switch port trunk native VLAN 1. So this is the command set given here. Switch port trunk native VLAN. In the slides it says 99, but for the purpose of practicals we use native VLAN 1. Then we have to say which VLAN traffic which will go in this line. Like in a in a highway, we don't allow this motorcycles and bicycles, all those vehicles to go. We only allow cars and above vehicle classes to go. Likewise, in when you create a trunk, we have to specify which VLANs that will communicate and travel using this trunk. So we have to say switch port trunk allowed VLAN add 20. So we have to send the 20 traffic. Again, we have to send the 30 traffic. Right? Then we have to say end. So this is the way that we configuring a trunk. So uh, here, of course, two VLAN traffic will go on the trunk. So that is why there are two commands. So if you have three, you need this last command 3 times by adding VLAN 20 traffic, 30 traffic, maybe 50 traffic as needed. The first two lines and the interface command won't change, and this one is the interface ID. So we can copy this command to the switch and see whether these ones works or not. So let's configure. Right. So I'm going to copy and paste this in the switch. Right. This one also. And in this one also I haven't done that. VLAN 20. Right. So now it's configured. Now only thing we have to do is to assign IP addresses for this PCs and try to ping from one PC to another in the same group and try to ping a PC in a different group. So same group it should work ping operation, and for the different groups it should not work. So we should try this now. So the description is given here. See that PC0 IP is given, 3 IP is given, 4 IP is given. So shall we configure this? So VLAN 20 PC0 IP given 192.168.21. So 20.1. So we will configure. So if you want to do the trunk commands, I will have this here. And first of all, you can configure the trunks, then we will assign the IPs. So I will give you about 5 minutes time to configure the trunk, and if you do finish up, let me know. Then we will go to assign the IPs. Okay, let's go ahead. We'll configure the PC IPs. So PC0, it's 192.168.20.1. We go to desktop 192.168.20.1, and PC3 20.2, 192.168.20.2. Then PC4, that is this one, 192.168.20.3. Then under the VLAN 30, there are two PCs. PC1, and PC2 192.168.20.30.2. Right. So let's configure the ping operation and see. So we will try to ping from PC0 to PC4. That is this one to this one. So that means the traffic should go along to the switch, then through the trunk line to the switch 1, then go to the PC4 and come back as a reply. So if it is working, we have configured the trunks correctly. So we will ping and see. So in order to ping, we go to the PC, then we go to desktop tab, then we have a run command here. So we go to the run command and we initiate the ping operation. So we type ping space PC4's IP is 20.3. So ping 192.168.20.3. Then reply should come like this. Reply form. So that means we have configured the switches correctly. So the replies are coming. And if we try to ping from ping to another PC in a different VLAN, for example, PC1, it should not work. Ping 192.168.30.1. The request timeout command. The request timeout should come like this. So that means in the same group, we have communication. If it is in the different group, we should not have communication because all these PCs are in the same switch, right? PC0 to PC2 I am trying. So it is on the same switch, but no communication because we have grouped them into different VLANs, right? So this is the concept behind VLANs where we want to group the PCs into different VLANs to for the administrative purposes. So in a large network environment, you may have about 10 to 20 VLANs, and the switches are, I mean, scattered across different buildings, and each switch port may be a member of particular VLAN, so that we can manage it easily. So this is the practical number 2 that we have saved. So I'm going to save it as practical number 2. Then we move on to the practical number 3. Any questions so far? ප්‍රශ්න තියෙනවද? Do you have any questions? So far we have covered several concepts. VLAN concept, assigning IPs to PCs, assigning configuring the passwords of the switches, right? So then we move on to the routers. Next, from the next practical. So routers are sort of devices which communicates between networks. Unlike a switch where they are in the same network, but the router's main purpose is to send traffic over different networks. So even though this practical tree is very small, it has very important sections that you need to learn. So please watch carefully. After that, you will you can do it yourself. So first of all, I will draw the router. So you can draw the routers with me. For example, I have 2811 router, 1841 routers, 3 routers. So I will click on the network devices, and from the router list, I click on the routers. From the router list, we pick the routers. Okay, so I have 1841 router first as a router 0, router 1 2811 router, and then again another 2 routers. So we don't have router 2, router 3 and 4. So we need to know how to rename. So I just rename the router 2 to router 4 by clicking on the place, right? So now we have 4 routers, right? So the changing names, you can do it yourself because the commands are equal for the switches and routers in order to change the names. Now, for example, the hostname command is same for the routers and switches. So you know how to do that. Enable conf t, then you give the hostname command, right? Then you have these banners. You know how to set the banners as well, same as for the switches. Only thing is you need to know how to add serial interface modules and the fast Ethernet modules to the router. So watch carefully how do I do. Now, supposing I have a 1841 router, I click on it, then you get this router's image. So this is actual image of a router's backside. Okay. So there's routers. So there are empty slots where we can fit additional interfaces. So initially there are 2 interfaces, fast Ethernet only, and you have a console interface as well. And in addition, you have 2 slots in the 1841 router, slot number 1 and slot number 0. So you can add the port additional interface cards which is there, we call them modules. They are out there in this side. So if you click on one module, so the description will be given here with the module name. So if you want to add a serial interface device, you can add WIC2T. But if you want to have a high speed serial interface, you have to use HWIC2T, right? So HWIC2T is the one we are generally using in our practical class and for the exams to add the serial interfaces. So how to add this? We just drag this one of this module and put it in a slot. So if the switch router is powered on, as you see with the green light, you cannot add the module. So we have to turn the power off like this by clicking on the switch. So we turn the power off, then we add the module. Then we have to turn the power back on like this of the router. Then only we can have this particular module working. So supposing now we have added it to the router 0. So if we click on the mouse closer to the router 3, see only for 2 fast Ethernet modules are there. But if you move closer to the router 0, you would see there are 4 ports. Fast Ethernet 00, Fast Ethernet 01, then serial 000, serial 001. So the serials are coming because we have added that particular interface. So for the 2811 router also, we have to add the interfaces. So we will learn how to add same scenario, but it has more interface slots, right? Than the 18441 router. So this is 2811. So first of all, we have to turn it off, right? Then we add a router. So generally we have HWIC 2T module. So we add into one of these slots. So the middle I will show first by adding it somewhere here, right? So this one is the serial interface card. So supposing we have added into the wrong slot, then what we can do is we can drag and drop into here, then it will be removed. So we will add it again. Right, then we have to turn on the router, then that module will work. So if we move mouse closer, it will show you the serial interfaces. So the serial interfaces will be named as serial 0/1/0, serial 0/1/1. So the middle one is the slot number, remember, right? So we have added to the slot 1, that is why the middle of the serial interface, the value comes as 1, right? Supposing if you add we turn it off, we remove this and we add it to a different port, like here, say different slot, and turn it on and see, then it will be shown as a serial 0/2/0. So the second one will change because we have changed the slot. So, but generally for the exams, we need to have serial 0/0/0. So now according to this one, we have add 0/2/0 for the serial. So that means our card is in the wrong slot. So we have to put it in the correct slot. So we turn it off and we drag out. The correct slot is this one, slot number 0. So then we turn it on. And if you move the mouse closer, the slot number changes. Now we have serial 000, serial 001. So likewise, you need to know how to add serial interfaces or any other interfaces to the slots as needed given in the topology. Hope you did understood what I am showing. So now you can try for yourselves. Any questions so far? Okay, so you can try that because in the next practical actually needs you to add these serial interfaces. So I will allow you to do the practical on your leisure. So we move on to practical number 4 because the adding ports is the one that I need to teach you in this practical. So we do cover it in the next one. So we will move on to the practical number 4. So you everybody please draw it with me. I will do it slowly. Practical number 4. Then we can continue and we can do the practical together. Right. So I will take a new one. And we have 2 routers here in the practical and 2 PCs. Right. And here it has serial interfaces. And here you have if you can see, there is a small clock here. So when you have a serial interface in a router, when you are sending the traffic, it goes serially. That means one after another. So that you need to have a timing in a serial interface. So which side creates the timer is shown by this clock sign. So we call it data communication interface side. In a typical network environment where this timer is set by a single side. So uh, I will show you how to draw this slowly so you can draw with me. First, let's add 2 routers. So this one, we go to the network devices, click on the routers. And then we have 2811 routers. So from the last one is the 2811 router. We add 2 to the topology, right? Router 0 and router 1. Then we have 2 devices, right? 2 PCs, PC 0 and PC 1. Then when we are connecting when we are connecting a PC to a router directly, we have to use a crossover cable. So we take connections here, and earlier we have used straight cable with a solid line. Now we use the dotted line one. It is called crossover. So the description nicely say copper crossover when you move mouse closer. So we click on here and take a copper crossover connection, and we connect the PC 0 fast Ethernet 0 to router 0 fast Ethernet 0, right? And on the other side also, we take PC1 fast Ethernet 0 and connect it to the router fast Ethernet 0. Earlier, you have seen that green lights have turned on, but here, of course, you don't see any green lights because the router interfaces generally turned off. So we have to tell the router, okay, turn it yourself. Turn it on yourself. So because of that, still they are off, but through the commands, we can turn them on. Now, the middle link is a serial link. So there's a connection like serial DCE connection with a clock sign. We have to use this connection to draw the middle line. However, the routers doesn't have a serial connection. See, only fast Ethernet. So that cable cannot be attached here. This one also fast Ethernet. So you cannot attach the cable. So it says cable cannot be connected to that port. So that means these 2 routers, we need to add serial interface cards. So, so what we do is, we take first router 0, we click on that, right? Then turn it off. And we need serial 0/0/0. Now, from the last practical also, I told you have to put the card in the correct slot. So we use SWIC2T module. and we drag it into this particular slot. This one is the slot number 0. So we turn it on. Then if you move mouse closer, now you have serial 000, serial 001 interface in the router 0. Similarly, you have to add to the router 1 as well. So you click on the router, turn it off, and add the HWIC2T module to the slot number 0 and turn it on. So everybody do it. Right. So then we have to connect it. So connecting is, now this clock side is from the router 0 side. So when we are connecting the cable, this cable has to be start from router 0 side where this clock is. So we click on the two-way double run router and we attach the serial 000 cable there, on that side, and we attach to the other side serial 000 in the router 1. So now the cable is linked. Now if you move mouse closer, sorry, then you see SC000 with a clock on that side in the router 0. And this one SC000 without a clock. So that means we know that this one correctly attached. But no communications yet. We have to configure. So the PC0 IP is given here. Now I will explain little bit of theory now before going further. Now in this particular topology, we have 3 networks, right? Uh, something like this. So if this side I change by the boundary of the network interface card of router 0. So this is a one network where PC0 and the network ID is there. It's like some normal our land yard, and if you want to have to go out of the land yard, we have to use the gate. So the gate is something like this, the network interface card of the router on that side. So if we want to go to that particular, from that LAN to outside, we use this gate. So typically in the networking terms, we call it gateway. In similarly, this side also again another network like another LAN, right? And there is a place here also to go out. So this is the place of the gateway of this particular network. And in middle, we have another network demarcated by 2 network cards of the router. So altogether, we have 3 networks. Now here, as you could see in the diagram, PC0 IP is 192.168.0.2, right? So that is, this network is 192 sorry, 192.168.0/0 network 24. This is one network. This one in the middle, router 0 serial interface is there in 192.168.1.1. That is 1.1 is the second network. 192.168.1.1/24, and the other side is 192.168.2.0. Right. So since it is difficult to tell the network numbers, I will rename this as network A, network B, and network C. So router 0 has two interfaces, fast Ethernet 0 and serial 0 interface. So fast Ethernet 0 is connected to A network and serial interface is connected to B network. So router 0 only knows about A and B network. And if you take router 1 serial interface is connected to B network, fast Ethernet is connected to C network. So in terms of router 1 knows only about B network and the C network, right? So the theoretical problem comes when PC0 wants to send a packet to PC1, because when a packet comes through this line, because it is going out here, and router 0 doesn't know anything about C network. So the packet will be discarded here, right? Okay. Because router 0 doesn't know where to send the packet to the C network. Similarly, if the PC1 was to send packet to A network, it sends to the immediate gate outside here to the router 1, and router 1 only knows about B network. It doesn't know anything about A network, right? So then we have to have a mechanism of educating these routers about the other networks. We call it uh, routing. Okay, static routing and dynamic routing algorithms can be used, or static routing, we can issue the commands in order to educate about the other networks to a different router. So if you take router 0, A and B is known, we call it directly connected, but C has to be taught. And similarly for the router 1, B and C is directly connected. However, A is not known. So A need to be educated, right? Is that clear, everybody? Make a පැහැදිලිද? Is that clear? Any questions? Regional centers? Okay. So is this concept is clear? Right. So we move on, and let's configure the IPs of the PCs first, and then the routers interface IPs. So for the PCs, we will start doing this, right? For the PCs, the IP first line says PC0 IP is 192.168.0/0.2/24, and the gateway IP that is here, which is going out, is given as 192.168.0/1.24. So we will configure the PC IP first. So we go to the desktop here. IP is given as 192.168.0.2. Mask is there, and the gateway is somewhere here. Now PC0, in order to go out, it has to use this particular point IP. So the IP of that router interface is given as 192.168.0.1. So the gateway will be 192.168.0.1. And the other one also we configure. Desktop. We go to the desktop. And PC1 IP is given in the practical 192.168.2.2. And subnet mask is 255.255.255.0. And the gateway is from the PC1 when somebody wants to send a packet this side. So it has to go out of fast Ethernet 00 interface of the router 1. And that IP is given here 192.168.2.1. So that will be the gateway. Right. Okay. So PC's IP configuration is done. So if you move mouse closer, the IP address will be shown like this. Here also IP address is shown like this. And then let's configure the IPs of the router. So this is very important, how to assign a IP address to an interface of a router. So we click on the router and we go to the CLI and it says, would you like to enter the initial configuration dialog? We have to say no and press enter, or else we can simply type Control C, right? So to come into the router prompt. Okay, which mode we are in now in the router? මොන mode එකේද ඉන්නේ? Which mode we are in now in the router? Router also has those 4 modes. User mode, user mode we are in. Yes, correct. So we will now learn the command of how to assign IPs to this particular interfaces. So I will now go towards doing the router assigning. So we will start configuring the router 0. So it says router interface of the PC0 side, that is this one, is 192.168.0.1. So we simply we have to go to the interface configuration mode. So we type enable configure terminal. Then we have to go to this particular interface, that is interface phase 0/1, sorry, 0/0. Then we have to assign the IP address. IP address given here 192.168.0.1. So IP address 192.168.0.1. Then we have to give the subnet mask as well, 255.255.255.0. Then we have to tell to turn on the router interface. So we have to say no shut. So an end. Then this is the way that we configure an IP address to a interface of a router. So serial, we have an additional command, but for the fast Ethernet, we can do using these 3 commands. We have to go to the interface, then we have to assign IP address, then we say no shutdown. So actually no shutdown like this. But I can, we can use the abbreviated form. So I paste this. So after I paste this command, you can see now this PC0 and router 0, this interface went up because I told to turn it on. So lights came up, right? So similarly, for the router 0. We will do for the serial interfaces also. Serial interface, we type SE 0/0/0, and IP address is given here in the third line. That is 192.168.1.1 in the router 0 serial interface. So 192.168.1.1 we set here. And for the serial interfaces, we have to have a clock rate of 64,000. So we, in the clock side, we give this command, clock rate 64,000. So only in the clock side, we have to give the additional command. Others all same. We have to give the interface ID, then we have to give the IP address properly. Then we have to turn on the interface by saying no shutdown. So we configure that and paste here. So that part we configured in the router 0. But this link hasn't came up yet. Why is that? Now we have configured the IP and we asked it to turn it on. Why it hasn't turned on? This one came up quickly, but this one didn't came up. Why? I hate you. Why it didn't came up?
Router 1 still don't give.
Yeah, router 1 is still we have turned on from the other side. So that is why it didn't came up, right? So we will do it for the router 1. So we do it on one go, right? Now here we did it one after another, but for the router 1, I will type the commands on one go because we can do it easily because we know now how to do for the fast Ethernet as well as serial. So router 1, we say enable conf t interface FE 0/0 IP address is given as PC1 side IP address of the router interface is 192.168.2.1. So this is given, right? And with the mask 255.255.255.0 and we say no shutdown. Similarly, we have the serial interface. So we type interface SC 0/0/0 IP address. It's given here in the third line. Router 0 serial interface IP is this one, and router 1 serial interface IP is 192.168.1.2. So we type 192.168.2 with the, and we say no shutdown, and we say end. Right. So on one go, we configured the router 1. So I copy this command set and paste it on the router CLI, router 1 CLI. So we go to the CLI, and here to go out, I can press Control C. Then in the CLI interface, I paste. Now it will move on and work. All interfaces are turned on now. So commands are given here. So you can type it and turn your routers, both routers, turn it on properly. Now I will give you time to practice this. Turn on both routers. Then I will explain how do we do this routing in between PC0 to PC1. So this part is very important because based on this, we built on the next practical, and the routing concept is pretty important to score full marks in the final practical examination. All right, we will continue. So as I have told you, there are three networks here. This one and this one and this one, right? So this one we say A, B, and C, right? So router 0 only knows about A network and the B network because A network is directly connected for the fast Ethernet, B network is directly connected for the serial, right? It doesn't know anything about C network. So in order to reach C, you have to go via this particular interface. So if a packet from PC 0 to go to the network C, this packet comes along this path, go out in from this fast Ethernet interface, then from the router interface, it has to go to this particular interface of the router 1, and then if it is handed over to this place, router 1 knows where to hand it over, how to go to the network C. So the router 0 has to be educated about how to reach C. So you have to tell that, okay, if a packet comes for the router's network C, it has to be directed to the this particular interface, serial interface 000 of the router 1. So this is exactly what we do using a command. We use a command, a static root command. So this is how we do. So for the router 0, we have to tell about C network. So this is the command that we use. IP route. The network C is 192.168.2.0. So and subnet mask is 255.255.255.0. And the place where the packets go in is this particular place's IP address, that is 192.168.1.2 router 1 serial interface. So it is given here, router 1 serial interface IP is 192.168.1.2. So at the router 0, we issue this command, IP route. We want to reach network C. Network C address is this 192.168.2.0, and the mask has to be given, and where the packet should be handed over to, that is this particular IP address, right? This place. So this is for the router 0. And for the router 1, it doesn't know anything about network A, this side, right? B and C, it knows. So if the PC1 sends a reply, then I will take a different color. Different color. So if a packet comes from this end, why it's red? Okay. Packets come from this end, it should go towards this line and go in from this particular place, right? So if router 1 is to reach network A, the network interface of router 0 here should be the place where we send the packets. So this is in router R0. This is the command we need. For the R1, we use the same IP route command to educate about network A. So network A is 192.168, sorry, 192.168.0.0 network. So we use the same command, IP route 192.168.0.0 network with the mask 255.255.255.0. In order to reach A, we have to use 192.168.1.1, that network, particular network. Right? So in order to reach here in the router 1, we have to issue the command IP route, this one, because it doesn't know about A network. And for the IP router 0, it doesn't know about C network. So C network is 192.168.2.0 because it is given here. See, 192.168.2.1 is the PC IP address. So 2.0 is the network address. If you calculate using that method that I have given you to find the network, you can simply get 192.168.2.0 as the network address. So these two commands we can issue you in the different routers. Then we can actually ping two PCs together. So let's, without issuing these two commands, let's try to ping from PC0 to PC1 when it says what happens. අන්න අහනවා one student asks router 2811ම ගන්න ඕනේද කියලා. Yes, 2811ම ගන්න ඕනේ. Right? 2911 විතරක් නෙමෙයි 2911 වලට එහායින් ඇති 2811. Right? So some student asks whether you need 2811 router. I say yes. If you click on this router set, right? The last one is the 2811. See here. But initially you will see now 2911. It's not the one I need. I need 2811. Right? Okay. So that is an additional question. So let's without configuring this IP route commands, we will ping and see. So from PC0 we will ping to the PC1. PC1's IP is given 192.168.2.2. PC1 IP. So we ping. So it says destination host unreachable because router doesn't know how to send the packets to that side, right? So now let's educate it with the commands that we have. Router 0, we have to issue the IP route command. So the IP route command actually has to be issued in the privilege mode. So we type enable conf t configure terminal. Then we type IP route 192.168.2.0 255.255.255.0 and the exit interface where we go the packets out to the C network is here. So that is 192.168.1.2. Then we exit and then we see the routes. Show IP route. So it shows you the commands. It says directly connected IP addresses are there. That is A network 0/0/24 directly connected. So A network directly connected. Then 192.168.10 is directly connected. That is B network. And for the C network 192.168.2.0, it is via 192.168.1.2. That is this exit interface එක හරහා ගිහිල්ලා you can go through that particular exit interface and reach the network C. It marked as S because we have put a static route. We call it static route. We have introduced static route to the router 0. Right. The command is show IP route here to see this. So in the router 1 also we do the same. Enable conf t. Now we have to say IP route 192.168.0.0 255.255.255.0, 168.1.1. That is, in order to come to A, you have to come via this interface, router 0 serial 000 interface. That is, router 0 serial interface is 192.168.1.1. So that is, we have entered. Then we type exit and you type show IP route. So it says 0.0 statically connected, others directly connected, right? So this, after this configuring these two routes, we can try to ping again from PC0 to PC1. So we ping 92.168.2.2. Then it will first try to find the path. So first one, it will say request timeout. From afterwards, it finds the path. It will get a reply. So that now that means PC0 can communicate with PC1, no problem. From the other side also, we can ping and see. One nine two ping. One nine two 168.0.2. So the replies are coming. So that PC0 can communicate with PC1 after introducing these static routes from the both ends. So this is very important lesson that you need to know when introducing the static route. You need to properly plan it by drawing like this. Then you can easily build the command here. Right. So this will actually covers about 80% of the things that we need to know about computer networking sessions that is needed for the practical examination. So that if you know up to this point, you can score over 70 marks for the practical examination. So let's go to the next practical. I will configure, I mean, we will do the next practical together and then we will go for a lunch break. Okay. So can you hear? Right. We will take draw the packet tracer file. We will draw this quickly. And remember, this is how you read the topology, right? It says the network is given 192.168.3.0 and the network is given here, and this dot one says the last digit of the IP address of this particular network. So how many networks we have in this particular topology? Can somebody say? How many networks? How many networks you have? Nobody is talking now. How many networks? How many? 4
7.
or 5, right? So shall we draw and see? So here we have one network here, this one, right? Up to this point, right? And another network here, up to this point, between two interfaces, and another network here, up to this point, another network here, up to this point, and last network is here, from here, right? So that is the 5 networks, right? So let's draw this quickly in the canvas. You can draw with me because it is very easy now. You know how to draw. So, and we will rename the display names also R1, R2, R3. So, shall we draw quickly? So, we have 2811 routers, 3 numbers. 1, 2, and 3. So, this one we'll rename as R1. This one R2. This one R3. Right. Then we have 3 switches, 2960 switches. 1, 2, and 3. Then we have 3 PCs, PC1, PC2, PC3. We go to the end device. The last one we rename as PC3. Right. Now we have it like this. Right. Then we have to connect. So here DCE means the clock side, right? So the IP address is also given. So shall we draw this and connect? So R1 we need serial interfaces. So we go and turn off the router and we add SWIC2T, this one, into slot number 0 here and turn on the router. And R2 also we go in and turn off the router. We add the WIC2T card and turn on this one. Again we turn off the router, add the card WIC2T to the slot 0 and turn on the router. Right. Then we have the serial interface to add. Right. Then we connect the wires. We go to the connections. Always we have the straight cables, port numbers given. So we connect. Fast Ethernet 0 to Fast Ethernet 1. It's given here. And use Fast Ethernet 02 of the switch to connect to the router Fast Ethernet 00. That means this interface is given in the topology. See, use FA02 of the switch to connect FA00. So that information is given. So here FA02 to connect to FA00. Similarly, other sides also we connect. PC3 fast Ethernet 0 to fast Ethernet 1, fast Ethernet 2 to fast Ethernet 0 to the router. Right. Then this one again we connect PC2 fast Ethernet 0 to switch fast Ethernet 1 and so I have added the wrong switch it seems. See, this is 2960, this is wrong. This one correct, this one I think I have added the wrong switch, so I will remove this and add the correct switch. 2960, this one, right, and add the cable. Fast Ethernet port 2 to fast Ethernet 00 of the router. Hurry. Okay, so now routers, when we are drawing the serial interfaces, you have to consider this, where the DCE is. DCE is the clock side. So we have to start drawing from the clock side. So we take this serial DCE, that is the connection, serial connection with the clock. So we start from this particular side where the clock is. So serial 00 to serial 00 of the router 2. And for the router 2 to router 3, serial side is the router 2. That is communication DCE clock side. So we draw it serial 001 to serial 001 there. So now this is the topology, right? I have saved it. Right. Then we need to configure the IPs. So IP is given, .5 is the last octet value of PC IP address that is given. So this network is 192.168.1.0. So the PC1's IP will be, last one digit is given as .5. So that means PC1's IP will be 192.168.1.5. And the gateway will be here. So it's .1 given, that is 192.168.1.1 is the router 1's fast Ethernet 00 IP address. So that will be the gateway also of the PC1. Right? Similarly, if we take PC3, the PC3's IP address would be 192.168.3.5 because 5 is the last octet it is given. And the fast Ethernet interface of the router 2 here will be 192.168.3. The last digit is given .1, and that is the place where the PC3 traffic goes into the outside world. So that will be the gateway. Likewise, you can plan for the PC2 also. We will assign the IPs. So we will start from PC1. So we will do this slowly. So the IP address I will assign 192.168.1.5. That is the IP. The gateway is here 192.168.3 1.1. That's the gateway, because the any traffic going out of this particular network will reach the router 1's interface, and from there onwards it's go out. So this is the gateway. So that gateway address is 192.168.1.1. So that is why how we configure it here. Similarly, for the PC2, we have the PC IP address is network is 192.168.5.0. So the last one is .5. So the IP address is 192.168.5.5. Right. The gateway is the address here. So that is network is 5. So .1 is the last interface, last octet address. So the router one's fast Ethernet interface is 192.168.5.1. So similarly, we do it for the PC3 as well. We go to the desktop IP configuration 192.168.3.5 is the PC IP address. Gateway IP address is 192.168.3.1. So that is the network interface card IP here, right? So this is a common knowledge, right? Now we close this to give the address. Now the router configurations, we'll start from R1. So I will use the notepad to build up the set of commands. So the R1 configuration, let's see how the R1 built up. So the fast Ethernet 00 interface we have to assign. So en conf t, and we have to say interface FA0/0 IP address we have to give. So 192.168.1.1 and mask is 255.255.255.0, and we have say no shut. So that is this interface, and this interface SE000. So I take a copy of here and paste it. Instead of FA, I put SE 0/0/0, and IP address is given here. So 192.168.2.1. Here one last digit is given, right? Mask is same, and this is the clock side. So we have to say clock rate 64,000. So then this will be the router 1's configuration. Then if I go to the router 2, again en conf t is there. Then I will take a copy from the fast Ethernet side, so easier for me to replace. So the fast Ethernet interface IP address is 192.168.3.1. So that is here. And fast Ethernet 00 interface correct. So then serial interface, I take a copy. So SC000 is this site. So the IP address is 192.168.2.2 here. So 2.2 here. And it is not the clock side. So we are not needing that one. No shut is needed for the SC000. Then I need another copy to configure this side, but this side is DCE, that is the clock side, but the interface is SE0/0/1. So I will add the interface SE0/0/1 here, and the IP address is 192.168.4.2. That is the interface of the router 2. Again, I will say 192.168.4.2. Here 2 is the last octet. And we need the clock rate 64,000 here because it is the clock side. So this is the router 2's command set. Then router 3, R3. So it is almost same as router 1. So we straight away take a copy, right? Straight away take a copy. And we configure fast Ethernet first for fast Ethernet 00. And fast Ethernet 00 IP address is 192.168.5.1. So we put it as 5.1. And mask is same. No shut command is there. And the serial interface is SE0/0/1. So that is here we take. And the IP address is 192.168.4.1 here. And we don't need the clock rate. So we only need no shut command for the end of the router. And say end. Yes. So these are the 3 sets of commands we need for the R1 and R2 and R3. So I will scroll this and keep it in the proper place. So you can see all the commands here. Sorry. Right. Okay. So these are the set of commands. So you can right. So you can configure now. I will give you time to configure, right? About 10 minutes. So the command set is given. So routers one by one, you type the commands and configure. Then I will configure myself. Okay, hope you have tried to configure them. So the command set is here, and if somebody is writing, you can write the command set also, right? So I am going to now copy this command set that I have compiled to the each of the routers. So R1, I am going to the CLI. And I paste it. So no errors came. So R1 okay. Then R2. I took a copy and go to the CLI. And for the R3, I took a copy and go to the CLI. Right. So all three routers now we have configured and came up without errors. So now we save this topology and keep and because in the practical it says configure above topology and do the static routing and then dynamic routing also, right? So the static routing we will first do because it is the hard one. Dynamic routing is pretty easy, so I take a copy, vertical 5, static, right? So now let me, hello. Okay. So the clock side cable, one student is asking how to do this clock side cabling. So I will show again. Now, if you want to connect it to the clock side, uh, it's something like this. You have added the serial ports, and then we go to the connections. Then we take this clock side serial DC connection, this one, this connection. And the DCE is the clock side according to the topology. So in the R1, we start drawing from the R1. So I will remove this link. I will delete this link and I show again. So we take the clock side, then we start drawing from the clock side. So it is serial 0, 0, 0 and up to the serial 0, 0 to the other side. So that is the technique to do, right? Hope you understood how to do the connecting to the clock side, right? So now let's discuss about the static routing. Very easy to configure. I mean, very easy to build up when we do this diagram, right? So actually, you have to do it. Watch the video and do it because now I have shown the clock side one by through the connections. Uh, for serial interfaces has to be added first. So if those are added only, you can see this, right? So I will explain it in the theory. So we have 5 networks here. This one, this one, this one, this one, and this one. Right. So we will name it as A, B, C, D, and E. Right. So now let me ask you questions. Right. If you take router 1, right, what are the networks it knows? If I take router 1, what are the networks that is directly connected to it? So those are, it is known, right? What are the networks? Use the English letters.
A and B.
A and B. Yes, A and B known. A and B known. A, B. So we need to teach R1 about C, D, and E. Isn't it? So A and B is known now, right? Isn't it? So then R2, what are the networks known?
C and D.
R2, it knows about 3 actually. B,
D,
C,
B,
and D. Yes.
B,
Oh, yes, correct. B, C, and D. And R3,
D, E.
D, and E. Yes. So others, actually we have to teach. So now how many IP route commands needed for the R1? Because it knows about 2, no? Another 3 we have to educate. So 3 IP route commands needed at the R1. And for the R2, B, C, D, and known. About A and about E should be taught. So 2 IP route commands needed for the R2. And R3, it only knows about D and E. So the A, B, C, 3 networks has to be taught. That is 3 IP route commands are needed. That's right. Let's build them. Right? We will build one by one. So I will take the notepad to this side. It's very difficult to manage this in a single window. Okay, now can take, right. Right. Let's start from R1. So R1, so we will teach about uh, 3 networks. It knows A and B, C, D, and E. We have to teach, right? So if I take if I want to find a path to C, the packets coming from this side, right? It has to go through FA000, SC000, and then go out of this place, right? In order to reach C, right? So the router 1's exit point is this point. If we want to reach C, and exit point is the same place for the D as well. Because if I want to go to the D, the packets coming here from here have to go out from this particular interface of the router 2. And in order to reach E also, the same point, right? So using that knowledge, we are going to build the router IP route command, right? So IP route. So first we have to tell about the network C. Network C is 192.168.3.0. Mask is 255.255.255.0. And the place where we exit interface, where we go out is here. So this place's IP address is 192.168.2.2. So this is to reach C, right? For the C network, this is the static root command that we need to issue at the router 1. So I take a copy because I am very reluctant to type, right? And we need to reach D. So D network is 192.168.4.0. So I change it to the 4.0. And the exit interface, if we are going from this side, will be the same, right? In order to reach D also, R1 has to send packet to this particular point where R2 will take over and send it to the D. So the exit interface, it will be the same. And for the third network, it's E. So that is 192.168.5.0. But when you want to send a packet out towards E, the R1 has to send it and hand it over to this particular interface of the R2. That is the same 192.168.2.2. Got my point? තේරුණාද? C එකට ගියත් D එකට ගියත් E එකට ගියත් මෙන්න මේ B network එකේ මෙන්න මෙතන තියෙන network point එක හරහා යන්න ඕනේ. If I tell it in English, no matter you go to C or D or E, you have to go out via this particular interface in the router 2, right? So then let's take R2. R2 knows about B, C, and D. It has to educate about A. I think my time is limited on doing the practical, so I'm having hard time because of illnesses. Anyway, we will cover practical 5 at least. We will wind up. So if I want to reach A network here, the point that R2, the router 2, has to send packets is somewhere here, right? So if a packet from R2 comes here to the R1's this particular interface, then it can be forwarded to the A network, right? If a packet from R2 comes to this side, to this interface here, and it can be forwarded to E network, right? So if R2 wants to reach network A, the exit interface is this place where 192.168.2.1. So that I will type it easy for me. 192.168.2.1. And if I want to reach E network here, the exit interface is here 192.168.4.1. Right. So now I know the values. So let's fill the other parts. IP root command. I want to reach the network A. Network A is 192.168.1.0. Mask is 255.255.250. And the exit interface is this place here, 192.168.2.1. Now this one also we fill up IP root 192.168.5.0 with a mask 255.255.255.0. Exit interface is drawn in the green, where this is the place we need to hand over the packets. So that is 192.168.4.1. So this is the IP root command for router number 2. Then router number 3. Again, if you take router number 3, this one, it only knows about D and E network. So we have to educate it about A, B, and C. So if you look carefully, right? if you look carefully, the packets coming from this side, in order to reach C, A, B, and C anywhere, it has to go out from this place, right? So any packets coming from this side has to go out from this place. So this point's network address is the exit interface in order to go to A, B, and C anywhere. So that interface IP address is 192.168.4.2. So it's pretty easy to build the commands for the R3. We take a copy of these three and you take one copy and change it. So let's do it about for the network A. So network A is 1.0 and the exit interface is the one drawn in the orange color. So that is IP address is 192.168.4.2. So all the others also it will be same. So the 2.0 network, which is B network, again the packet should come via here. So that is the exit interface 192.168.4.2. The third one, 3.0, exit interface is same. So we have built up the routing commands for all three routers now. So this is the way we build. We just circle it and we find out the exit interface, right? Then easily we can write the static root commands, right? Okay, have you got this thing? Meka පැහැදිලිද? Have you got this thing? Is it clear, all of you? The theoretical part? Any questions? Okay, right. So the people who haven't understood, I mean, you can watch the video again and again. So this will be explained. And let's copy these commands to the routers. So start from router 1. I will copy this. Annotations I will clear. Right. Right. So enable conf t and R1 we put these three commands. And for the router 2, enable conf t, we put these two commands. And for the router 3, we put oops. Right. So the routing commands are in place now. Now we can simply ping and see from PC1 to PC2 whether it works or not. So PC1, we will go there and go to the run command, and PC2 IP address is 192.168.5.5. So ping. Then replies are coming properly, so that means it will work. So the others also you can ping and see, it should work. Right. So we can also use a simulation mode of the packet tracer to see whether it works or not. So we go to the simulation mode like here. We click here, simulation mode, right? Then I will expand this and show you. Then here we have a simple PDU one here. We click there and we put a packet here and we ask to go here. Right. Then we put it in the simulation mode. Right. Then visually the packet will go. Then we can find out where it went wrong if it is not successful. Right. Then the reply should go. Right. So it will show you the status as successful. Right. So that is how we put it in the simulation mode. Then we do it. So right, we will put it in the real time mode and then this is the static routing. Now the dynamic routing is pretty easy. So I will load the one which is without routing. So I will save as dynamic. Right. So when the number of networks increase, it is very difficult for us to configure them statically because we have to educate about each and every network to all other routers. So if the number of networks are over 5, it is very difficult to track down all these static route commands. Right. So because of that, there are routing protocols developed. So one is called routing information protocols. It's called RIP, not rest in peace. So therefore, we try to build a command which is applicable for all the routers. So RIP is a dynamic routing protocol. Configuring commands. So it is very easy. So what we do is we simply go to the global configuration mode. So enable conf t, then we say router RIP, then we have to say all the network IDs. So we have in this particular topology, we have about 5 networks. So we educate it, say network 192.168.1.0, and similarly all the other networks we add 2.0, 3.0, 4.0, 5.0, and we say end at the end. Then the routers will educate themselves. So all 3 routers, we only have to enter the same command. So because we tell there are 5 networks, then routers will find out the paths. So we copy this command and we put it on all the routers. And this one also. right? So you can see while I do. Right. So after entering this, right, the routers will communicate with each other using RIP protocol, right? Right, routing information protocol. Then it will learn about the different routes it has, right? So then we can ping and see whether it finds the other paths. So we ping 192.168.3.5. That is this PC. This one we ping from here to this place. So we will see whether replies are coming. The first it will try to find the route. So request timeout comes, then replies should come. Yes. Okay. So with this, the dynamic routing protocols we can learn, right? So I will save this. So it is very easy to configure dynamic routing protocol than configuring the static route protocols, static routing. Oh, so with this, I will finish up for the lunch session, and it's time according to my clock. It's 12:36. Shall we come back around 1:15? Okay. So while 1:15, I will start the evening session. In the meantime, you have your lunch and come back. So 1:15, I will start, and I only have to cover the this particular practical 6. Then I will wind up the class. The rest, the two ones, this one and this one, you can do from the knowledge that you have gained from the practical up to 6. Okay. So I will upload the videos of how to do practical number 7 and 8. So up to 6 I will cover. So we will come back, assemble at the regional centers if they are here, they are at 1:15. So we will start the class. Okay. With that, I will post the session. So please come back at 1:15.